All right, welcome everyone, and thank you for joining us today for our digital Q&A session, where we'll be joined in a moment by Liz Pearce. Before we properly get started, I'd just like to acknowledge that we are on Ghana land here, where I am speaking from, and I'd like to acknowledge their connection to the land, the sea, as well as the skies above us, and also acknowledge any Indigenous groups from wherever you might be joining us from today. I'd like to acknowledge that the Indigenous Australians are some of, if not the world's oldest astronomers, and so have been looking to space and using space to inform them for hunting, storytelling, navigation, things like that for a really long time, long before, we've been sending people and rockets into space. So my name is Georgia Bowden. I'm a space communicator here at the Australian Space Discovery Centre. And as I say, we'll be joined in a moment by Liz Pearce, who works for the Australian Space Agency. Now, throughout our chat today, if you have any questions, feel free to drop them in the comments and we'll get to them when we can. Otherwise, definitely come join us in the centre here anytime for any further questions you might have. Just one last note before we get started. Our session will wrap up today at about 2:45 p.m. Australian Central Standard Time. So again, if we don't get a chance to get to your questions by the end of the session, feel free to drop us an email or come visit us in centre with those. All right, now I would like to welcome our special guest, Liz Pearce, who is joining us today from the Australian Space Agency. Liz, would you like to introduce yourself a little bit?
Thanks, Georgia. Hi, everyone. Welcome to the session today. I'm very pleased to be here. I also come to you from the lands of the Kaurna people. I'm here based in Adelaide, and the Indigenous population in the agency is something, in Australia, is something that the agency is really, really passionate about. And if you don't know more about it, I encourage you to go to our website. We have a great video, actually, that explains our logo, if you can see it in the corner there with all the dots. It gives me chills every time I watch it, so please encourage you to have a look. So I'm here today to tell you all about me and answer any questions you have, and I encourage anybody listening today to ask anything you want. I'm pretty open about anything that I'm asked. I'm keen to share with you my journey through my career to getting me to the Australian Space Agency. It was definitely not a straight line. If you jump to my first slide, I can show you how very squiggly that line was. Going from high school up in the top left all the way to the agency in the bottom right. It's been a very zigzaggy line going through space weather, which is what got me interested in space in the first place, and where I learned that data analysis is the most amazing thing in the world and everyone should do data analysis. Via Defence, I went to Defence Science and Technology Group. So there's some of the pictures in the top right and the very bottom left. And then finally through to the Australian Space Agency. And there's a lot that's happened along that journey. A lot of things I've discovered about myself, a lot of things I've discovered about science and technology that I think it's just really exciting, and I'd love to share that with you if you have questions. But also I'd like to talk to you, if you're willing to hear, about how to balance that life with your own personal life. On the next slide, you'll see some of the elements of my personal life that I'm really keen to talk to you about, how to balance a science mind, a science and technical mind, with creativity, which is something I struggled with for a long time. How to do creative things when you think very logically, very straightforward, which has led me to some wood carving, which you can see there, and also share my personal journey, the outreach things that I've done, and some of the places that I've been able to go to as part of my work career. So that's the breadth of where I'm willing to talk about today, including if anybody has questions around Catherine Bennell-Pegg, Australia's astronaut who graduated last week. Phenomenal, amazing event, world first for us. I'm very excited to share anything that you have questions about that. So please ask anything, ask a lot, and I'll do my best to answer those questions. Thanks.
Fantastic. That's an awesome introduction. So I think we might start just talking a little bit about your role within the Australian Space Agency. So if you could paint us a little bit of a picture of what a day in the life kind of looks like and what sort of things you deal with and look into in your role, I think that would be a good starting point.
Excellent. So at the moment, my role is the Acting Director of Space Transportation and Human Spaceflight Team. So that's the team that deal with rocket launches, orbital things in space like space stations. There's a new age coming of post the International Space Station where we're going to have commercial space stations in space run by commercial companies. So there's going to be a bunch of them. And we also look at human space flights, humans in space, space medicine, space health, and of course that includes Catherine Bennell-Pegg. So I work closely with her, making sure that she's got everything she needs while she does what she does in Germany. And we're actively working to bring her home after her graduation so that we can learn everything that she's done over the last 13 months. So that's what I'm doing at the moment. In the past, I've done a lot of other things. So I've had a few roles within the agency. I've been previously the lead for positioning, navigation and timing, which, excuse me, was a role designed to understand the capabilities in Australia in the commercial landscape. So the companies, the industry, the people at university who know things that can be shared with the world. So that was a lot of fun trying to understand a national capability and how that fits in with the world. And that also led me to talk to people overseas. So I every so often get to talk to NASA, and I still giggle every time I talk to NASA. So that doesn't go away. It's very exciting to talk to NASA. This morning I got to talk to SpaceX. So I still giggle when I talk to SpaceX too, because you hear about them a lot, and we get an opportunity to talk to these really big, important people and try and make a case for Australians and Australian companies to play on such a big landscape. So I've done that, and I've done a little bit of the same sort of things around space situational awareness, which is looking at space objects, tracking them, knowing where they are, knowing where they're falling. We've had a few debris re-entry events over Australia in the last few years, which is concerning, and it's only going to get worse as there's more things put into space. And I've also been a little bit across the robotics and automation subject area. So there's a roadmap that's published on our website that you can go and have a look at. I was part of the team making that a reality, which meant, again, talking across the country to everybody and who they are and what they're doing and how we can actually sell that as a capability to the world, but also how to take things that, for example, in the mining industry, and how to take that terrestrial capability and translate it into something that we can use in space. We're Australia's part of a signatory of the Artemis Accord, so we're part of the Artemis program, going to the moon, going on to Mars, and how can Australia be a part of that? So that all sounds really big and shiny and amazing. Day to day, it can be as simple as just planning, thinking about what we want to do next. How does Australia be very strategic in what we do? Emails, meetings, talking, phone calls, those kinds of things. And then you have those big momentous days where you talk to NASA or you talk to the European Space Agency and have those really big, impactful conversations, which sort of stay with you when you think about what we're doing for the country. So that's a long-winded answer to what I do in my role.
No, that was fantastic. It sounds really awesome. You spoke a little bit about talking to NASA and talking to SpaceX and things like that. We've got a question from April, one of our viewers, asking, how does international cooperation affect space exploration? So that might be a nice lead in to talk about that a little bit.
That's a great question. Well done, April. So it's very important to be collaborating internationally. Space isn't owned by anyone. And as humanity emerges into space, the problems that we'll face are more than Australian problems, more than US problems, more than Europe problems. They're humanities problems, biological things, resources, power management, health, all of that it's the same for everybody, and it makes sense for us to work together to do that as a species rather than as a country. Obviously, there are elements that each country will prefer to pursue first. Each country has their own priorities, and Australia is no different. That we have what we need to do to keep our country safe and keep our country prospering. And so each country has their own perspectives. But as we move into space, we need to do it together. It's expensive, it's hard, it's risky. Space is hard. It's a saying that goes around a lot. And it helps when you have friends to help you get there and get past the hard. And space has always been a great unifier, I believe. It's inspiring, and it's something that we can use to overcome any differences between the different countries around the world. And to exemplify that, Australia is part of the United Nations COPUOS programs, which I can't recall the acronym right now. Peaceful Uses of Outer Space is the last piece of that, and it's a United Nations forum for all nations to come together and decide how we work together in space in a way that is beneficial for all parties. So it's incredibly, incredibly important.
Absolutely, thanks. That was a fantastic response. Now, Eliza, another one of our viewers, has pretty much preempted my next question, so that's awesome. I was going to ask you a little bit about your journey in getting to where you are in terms of, just how you got there. So her questions, sorry, I shouldn't assume, that viewers' questions refer to what subjects you focused on during high school to help you prepare for your career in the Australian Space Agency, and about perhaps what you might have studied in university. Or I was going to also ask about just personal interest or clubs or things you might have joined that might have also helped you get to where you are.
Sure, great question, Eliza. My journey has been very strange. I've been watching Catherine Bennell-Pegg with her journey, and she knew from a very, very young age that being an astronaut is what she wanted to do, and that's just her path for eternity. I did not have that path. I didn't even really know what science and physics was when I was in early university. I didn't even realize that I was interested in science. I couldn't have said that out loud. What it presented as, I was just interested in how things worked and asked a lot of questions, annoyingly in a lot of cases. But I was busy, I was excited, I was outside, I was playing in mud, figuring out how to build things. I played with a lot of Lego and a lot of Meccano was one of my favorite things to play with. And so when it got to around year 9, we had a science class there, and that was where I had my first inkling that science was a thing that I should be pursuing. Had a teacher who identified that I was doing exceptionally well for the class, which surprised all of us, really. We didn't expect that to come, and I was a bit taken aback. Oh, okay, this is a thing I need to think about. I didn't really, was just the way thing was, and I thought everybody was like that. So moving into year 11 and 12, where I had to choose subjects, I chose chemistry and physics and 2 different kinds of IT courses. One was a vocationary course, and one was that ended up like in a certificate too. And the other one was, at the time it was called Information Processes and Technology, which was general computers and how to use them. I was under the impression when I went into year 11 and 12 that chemistry would actually be the thing that I would gel with more than physics, because I actually didn't know what physics was at the time. No one could even tell me what physics was at the time. I thought chemistry would be my jam, because blowing up stuff is fun. That's how I viewed it. Turns out blowing up stuff is fun, but I didn't gel with chemistry particularly well. It didn't naturally sit in my brain. I couldn't really follow it like intuitively. I had to really work at understanding what was going on. Whereas physics, I went into it blind, not knowing what it was, and fell in love. Absolutely, just I love physics, and that became clear to me at parent-teacher interviews. My physics teacher, and I just went off on a mental journey of physics, and my mother was sitting there going, okay, I don't know what happened there, but you obviously are talking the same language, so I'll just let you go. So physics was the thing that I really loved at high school. I didn't do any biology. I did maths. I did not do extension maths. Maths was not my strongest suit, so that's another weird element of my career. I did well in maths until we got to sort of year 11 and 12, like deep calculus stuff, and then I really started to struggle. So I was sort of middle to top in my maths, but I wasn't right up there with a lot of my classmates. So I managed to figure out all the tricks to make maths work. So if you're having trouble with maths, there's always a trick to it. You've just got to find the people who can tell you what the tricks are, and it makes it a little bit easier. So moving from there, when I did my what's called high school certificate in New South Wales, I topped IT. Physics was probably my third or fourth best subject. IT was what I topped because I finished the assignments, and the way the grading structure was the assignments were the bulk of the score rather than the test, and because I finished the assignments, I topped the class. And so I thought, leaving high school, I don't think I'm smart enough for physics. I'll go and do IT at high school. And I lived in a town called Coffs Harbour, which is in the mid-north coast of New South Wales, and there was a university in town, Southern Cross University, and they did an IT degree. So that was easy. I didn't have to go anywhere, didn't have to really move or do anything. So I went and started IT at Southern Cross University. Got to what they call the HEX date, so it's 4 weeks into your degree where you have to make the choice whether you stay and pay for it or leave and don't pay for it. Got to that date and left because it was not my jam. I did not did not gel with IT at all. I hated it. I like using computers. I don't like programming computers. So I left and continued working at Big W, which was my part-time job, and I didn't do anything for a year. So it was like a gap year, an unintentional gap year. And I worked, I went to the clubs, played with my friends, did just nothing really. And then about halfway through that year, because I was convinced I would never go back to uni, never going back. I would try and be a receptionist. That was my career goal because I like typing, like organising things. There'd be a receptionist, couldn't get a job. There was a lot of unemployment at the time, so it was really hard to get a job as a receptionist. So about halfway through the year, my friends who'd worked their way up the Hungry Jack's management chain, their high school job, they'd worked all the way up to the store manager, and so they were starting to buy things and get rental properties. Like they were starting to be successful. Had a bit of money to spend, and I was really jealous. Oh, I want that. I wish I had that. And they said, well, why don't you go back to uni? And I said, nah. They said, what do you love? I said, well, I love physics. They said, well, go do physics at uni. Oh, I'm not smart enough. I'm not smart enough. Do it anyway. Okay. So I did. So I went and got into physics, went to University of Newcastle, which is not too far away from home. I was not keen on moving away too far, and did a Bachelor of Science with a majoring in physics. Ended up with an accidental nearly minor in chemistry because I didn't understand how you have to work your first year subjects to make it all the way through to your third or final year subjects. So just accidentally had to go through with chemistry because I made too many silly choices in classes. Nearly failed my first year because I had moved away from home and went a little crazy and had a lot of fun. Didn't study very hard. Didn't know how to study, to be honest, because a lot of things had come naturally to me up until then, but university was where it sort of all hit me that you need to actually work to learn. So that was a new experience for me. So picked up over the years and ended up with a degree in physics. My final year, so my honours year was ended up being in space weather, and that was pure luck in the sense that there was a great space weather cell at the University of Newcastle, and they were very passionate, and so I just caught their passion. It was contagious, and so space weather is where sort of I started to specialise into space physics. So if you don't know, space weather is the Sun-Earth relationship, how coronal mass ejections and solar flares and particles and magnetic fields and so on come from the sun and how they impact Earth, and what that means for people on the Earth, people in space, people on planes even. All very fascinating stuff. Ask me a question on it and I'll talk for the next 3 hours. Yeah, so that was my honours year, which led to a job at the Bureau of Meteorology. in the space weather services for 12 months. It was a 12-month position, which was the best fun, where I really learnt about data analysis and making an impact with the data that you're using and how you give the answers to people, how you explain things in a way that people understand. And then I was very fortunate to get into Defence Science and Technology Group through their graduate program after that, and worked into P&T, so that's position, navigation and timing, so GPS stuff, but all aimed at defence, so how to protect our soldiers and our country from adverse effects, and also how to make sure that they have everything they need to do their job. So it was there for a couple of years, moved towards robotics and autonomy as sort of an alternative navigation kind of pathway, which led to a bit of robotics, a little bit of autonomy. And then I saw the space agency start up and thought, ooh, that looks good. Let's do that. And saw a job come up and went for that job. Didn't get it. To be fair, Catherine got it. Catherine Bennell-Pegg, she won the job, and hands down, she deserves that job. But they needed someone to work for a near term while Catherine moved over from Germany, and so I was that short-term solution. And here I am, still here, haven't left. So it's been a very all over the place approach to get here, and it started with me not believing I could do physics. So if there's people on the call who don't believe they can do physics but love it anyway, do it anyway.
That's fantastic. Really awesome to hear how it doesn't have to be a linear pathway. How, I think most of us have various pathways that we've gone through. I know plenty of my colleagues here have had almost 2 or 3 other careers before they've ended up working in space. So really great to hear your story as well. On the subject of Catherine, I would love to talk a little bit about her for a moment. So as many of us know, Catherine is the first Australian to be trained as an astronaut the first astronaut to be trained under the Australian flag, who just graduated early last week, which is very exciting. So how have you been sort of following her journey? And yeah, if you want to talk a little bit about her.
Sure. It's been a really fun 13 months she's been there. I've been involved in her pathway for the last, say, maybe 10 months. So I talk to her every week, which is great, and help navigate what she's doing, what that impact is back home. So she sort of downloads on us every week on what she's learning, the classes she's doing. She sends back photos of, Earth observation or how the ISS runs, things like that. Shares all this really exciting information, and you can feel the energy even in the text messages, the excitement that's coming from what she's learning. So she filters everything back to me and my team. And we're collecting that in a sort of repository of what it means to train as an astronaut, so that we know. That's part of the reason she went, was to understand what it takes to become an astronaut, what it takes to for an education background. She grew up and was educated in Australia. So if you're being educated in Australia and want to be an astronaut, you have the education background. That I think is really important part of what we're learning here. And she's doing, well, she did. She's basically finished now. She did very, very well. She was very competitive with her amongst her peers. And by competitive, I mean that she was skilled equally with the group she was with. They were all great friends. So we'd talk every week. We'd talk with the European Space Agency as a whole and understand, learning from them what it means to have an astronaut in your country. This is the first time we've had a government-backed Australian astronaut with a flag on their shoulder. All the other previous programs have been through other space agencies. So this is a first for us. And so we're doing a lot of work trying to understand what that means. What do we do with that? How's this sort of work with the future? So it's been a lot of fun. There's a lot of people who want Catherine to work with them. And so part of my job is to look at who wants to work with Catherine, how we can use those resources to make Australia's case better. We've had some really fantastic opportunities with the European Space Agency to actually take over to Europe a group of Australian industry representatives to actually show ESA that Australia have things to share that are more than just an astronaut, because there's no just about it for an astronaut. But there's sort of a sub work going on here to show off Australia, show off how we work. We often get the feedback that Australia is very unique in how we approach our problems. We're very innovative in very different ways. And as a nation, I'm so proud of that, because we come up with all sorts of weird ways to solve problems with, either less money or less cost, less people, because that's the way our country is. And we do it really well. And it's really proud to show off Australia on a global stage. So we talk to Catherine all the time, and I can't wait to have her home to see her in person again and give her a big hug.
Fantastic. Yeah, I think many of us are looking forward to hopefully seeing her again when she's back.
Yep.
I think that's a great point to sort of segue into talking about the Australian space industry. So I've got some questions I might get to in a moment, but first we've got one from Andrew, who's said that your role sounds fantastic, and they are currently participating in the Milo Academy. And do you see many opportunities with the Australian Space Agency, or you could probably expand to the Australian space industry as well, outside of Adelaide?
Great question, Andrew. I think there's a lot of opportunity for the space industry, the space sector, whether you're still at university, whether you're, postdoc academic-ing, whether you're in high school even. There's a lot of opportunity. Space in Australia is growing so fast, and the Space Agency has been working quite hard in the background to make our presence felt on a global stage. And so there is more and more interest in Australian industry, Australian capabilities, even Australian students, to see how they can leverage us and what we can do. So I think what's really important from an Australian perspective is really understanding how we're different. What is it that we bring to the world that's different to others? And you can take that to an industrial scale. What is the company's difference? What is their edge? But going down, you can go down to the individual level. What is it that makes you different? One of the things I've struggled with for a lot in my career is understanding how I make a difference, and what's my role? What do I do? And I sort of have always sat in this sort of middle piece between the science and technology people who are very focused and communicating. So I very almost went for your job, the space communicator's job. I think it's so powerful and so important, and communicating science is something I'm really passionate about as well. And so I sort of sit halfway between the two and didn't feel like I belonged in either one camp, and that was a bit difficult. And what I've discovered over many, many years of my career is that being able to translate between them is important. So translating between the different users, translating really complex science and technology into general terms that anybody can understand, and understand why they need to know what I'm telling them. So that's what I find my sort of piece to contribute is. And Andrew and others who are on the call, I invite you to think about what is it that you can do that is different to those around you, and that would be of interest to Australian companies, to international companies, to international space agencies. Australia is getting a reputation now for being an innovative, very clever place to grow its workforce, and they're starting to come and want to work with us in very, very exciting and strange ways. And the Space Agency is doing everything we can to make sure those opportunities are seen and felt, and we share as much as we can. And I think the most important thing we do is raise the profile internationally. So even if it looks like we're not doing a whole lot domestically, we are out there, we are at conferences, we are at meetings, we're talking to all of the big players around the world to say, come to Australia, look for your people here. We are very good at what we do, and you have a part to play on the global landscape.
Fantastic. That was a great summary, I think. Linking into that, you covered it a little bit, but we have another anonymous member of the audience asking a little bit about roles in the Australian Space Agency, or again, I invite you to expand into the space industry in general, for those who may not have formal degrees or backgrounds in STEM areas. So I myself don't have a formal STEM background, but those sort of communication roles that you spoke about are one such example for, those of us who didn't study science or maths in university. But what other sort of areas or roles could you talk about?
It's a great question, and I think it's something that's really important. So the Space Agency itself is made up of a whole range of backgrounds. There are technical people and science people, but there are a lot of non-technical background people who are doing very important work. So as a government agency, it's our responsibility to provide advice to the broader government and work at that government to government level around the world. And communication skills are one of the most important skills there, and understanding the political dynamics, the social dynamics, economics. If you take it to a high level, I'm talking from a public servant perspective here now, the public service role is to protect the country, to protect the Australian way of life, and to make sure that we have everything we need to do to continue living the way we are. Our way of life is something that is very important to us, and space plays a big role in that, enabling everything we do around the world. It enables our communications. We are having this call right now because of space technology, and you don't need to understand the space technology to know that that's important, and that needs to be protected and encouraged and supported. So there's a lot that goes to communication. There's a lot that goes to policy. Excuse me. There's a lot that goes to international relations. How do we engage other nations in a way that is respectful both to their needs and to ours? So there's a lot that goes there, and there's also the humanities and the arts side. So space, particularly human spaceflight, has a lot to do with health, biology. You think about astronauts in space, there's a lot that physically happens to them. There's muscle degradation, there's bone degradation. It's actually quite hard on the physical body being in microgravity. And the research that goes into making life easier for astronauts is directly relevant to a lot of people on Earth in terms of osteoporosis, muscle and bone management on people on Earth. And so there's work for those who understand the humanities, like isolation, for example. Astronauts in space go through a lot of isolation problems, and how to handle that, mental health as well. And that is very relevant to space. It's relevant to Earth. So I would say anything is relevant in this context. It's how you bring it to the team. So, pardon me, if there's something that you're passionate about that's not technology and science, but space is something that you want to be involved in, then become good at whatever it is that you have to bring to the table. If it's communication, if it's policy, if it's politics, if it's humanities, life sciences, the psychological elements, all of it is relevant. So at the Space Agency, the key things that are important to work at the Space Agency is to, first of all, be an Australian citizen. That's a must. And the other thing is to be able to work at that high level, what's important for the country. You put yourself sort of in the background. It's about the country. We're here to support the country and what we need. In the industry, it can be the same. It can be different depending on the company you go into. Obviously, there's a lot of people that are needed in support. So there's finance things, there's HR things, there's the media stuff. So sort of what we're doing like now, but there's a whole team of people who promote things on social media, who understand how social media works. It's still something that's just slightly over my head. I don't really get social media 100%, but it's here, and I'll roll with it. But there are people who know that way better than I do, and they are desperately needed because times are changing, and there's a space for everybody. And for industry in Australia, I think citizenship is important, but not a must. But there's a lot of the space industry that serve sort of the civilian aspects. So that's what the Australian Space Agency is. We look at the civilian elements of space, but there's the defence side as well. And the industry that support the Space Agency and the industry that support defence are the same industry in Australia, because we're too small to have separate industries. So there is a lot of overlap between defence and civilian work. And so if you want to do defence work, you do need that ability to be trusted, honest, and get clearances and things like that. So they're definitely an element there. So I think if you want to be in space, you'll get into space. There's definitely a path in there. It's just a matter of how you do it and understanding yourself. Self-awareness is, I think, the most important thing that you could possibly do. If you know who you are and what it is you bring, then you'll be fine. And if you don't know who you are and what you bring, that's great. You've got a journey to figure out what it is, and I encourage you to try things. That's the best way to know. Try something out. You'll either know if it works or if it doesn't. Like my IT degree, I tried it. Definitely not for me. So that's the advice I have there.
Awesome. That was great. Some really good advice there. I think that idea of there's space for everyone in space is really a message that we do try to sort of push here a bit. So for anyone listening who does kind of want to see themselves in a space industry but not quite sure what that might look like for them, I would definitely invite you to come into the Australian Space Discovery Centre, because that is something that we love talking about here and helping people find what kind of space roles they could see themselves in. But I think you've offered some really good advice on that as well. Now, obviously not everyone is interested in a space career, but that doesn't mean that space isn't still really important. So you've touched on it a little bit, but I think would be nice to, as we come to the end, just talk briefly about why we as Australians should be paying attention to space technology and the space industry and how it sort of impacts our everyday lives here on Earth, as well as obviously out in space.
Sure. So as I mentioned, Australia is very space dependent. Being where we are, like in the world, like our physical location on the map, leads us to need space to support us. The fact that we also have a very big landmass and a very distributed population means we need space to support us. So the communication lines, we have satellites that support communication with the internet, with phone calls, things like that. That's all space. You can do it by cable, but it gets very hard, gets very expensive. And with the needs that we have these days, with connectivity, immediate response, all of that kind of stuff means it's space that needs to give us that capability. So we've got satellites in space for comms. We all use GPS or GNSS if you want to be generalized, which is the Global Navigation Satellite System. So that is the broad umbrella term for all of the different constellations. So GPS is the US-owned one. Then there's a European one called Galileo. There's a Chinese one called Beidou. There's a, come on, Liz, you can do this. There's a regional Japanese one called QZSS, and Quasi-Zenith Satellite System, I believe it is. Australia has its own augmentation system called SouthPan, that's run by Geoscience Australia. All of this, they all boil down to position, navigation, and timing. And there's two parts to that: positioning. So you get your Google Maps out, and that all comes through from GPS, probably a little bit of Galileo. GLONASS, that's the other system, which is a Russian-based system. So positioning is in your maps. It's in your phone. All of your mobile phones have a GPS. I think most of them have GPS, and some are starting to have Galileo and GLONASS chips in them as well. So they all have that chip in there. So you're getting that. So when you know where you are, when you're getting your directions to whatever, that's all space. The timing signal that comes from those satellites is actually completely embedded in everything. So our energy grid, they use the timing signal for synchronization. That's very important for power distribution. Also for our banking system, so the timestamp on your banking transaction, they need that down to like the nanosecond. It becomes very important from like an investment perspective. The stock market, I don't really get the stock market, but it's a big deal, the timestamp of those transactions, because if you miss it by a second, then you could miss out on the transaction completely. So very, very, very important. It's in our rail system, it's in our transportation system. We use GPS for precision agriculture, which is tractors and driverless tractors and things that are doing very precise farming that reduce the cost of pesticides and the misuse it, not misuse, but the words are failing me right now. But you know, making sure that the tracks that they drive, they don't overlap, so they don't use too much fertilizer or pesticide or things like that. So it's everywhere. It's in every element of your life. If you use a TV, if you use a phone, if you use the internet, in any way, it's you touch space every day, and we need to support space to keep that going. If we didn't have space, we would go back decades in terms of our capability and our connectedness, and that's something that the government is really keen to support, is the resilience of our critical infrastructure, and space is a big part of that.
Awesome, fantastic. We are a couple minutes out from the end now, so I might turn to just some of our audience questions for the last minute or so. We'll see how many we get through. We have a question from Marnie asking, how does space debris impact rocket launch and satellite operations? Can you speak much on that?
Great question, Marnie. It's a very big impact as far as I'm concerned. Space debris is getting worse and worse and worse. And if you're ever in Adelaide and get to go to the Space Discovery Centre, there's some really great things you can play with in there, where you shoot lasers at debris and try not to set off the Kessler syndrome, which is where one debris breakup causes another 100 debris breakups, and they just keep escalating until space is unusable. That's not the goal. Let's not do that. So for rocket launches, there's a lot of planning that comes into the trajectory. So trajectory is, you know, the path that you plan for the rocket to go through the atmosphere and up into space. And where you want the end point to be will determine what your boundaries are and how you set your trajectory. And then there's a whole monitoring element to this. So there are groups around the world who do space monitoring, and that's monitoring active satellites, but also the debris. So that's knowing where they are. There's a catalogue. You can go and look it up, actually. Spacetrack.org is the website where you can go and have a look at all the different things that we know about. There's heaps up there that we don't know about and are too small to detect. So I think we can detect things down to about 10 centimeters-ish. But it's, you know, even stuff this big in space is extremely damaging because it's moving so fast. So it's moving like a bullet. So even paint flecks can be incredibly damaging to spacecraft, to people, to the ISS. Every so often the ISS has to move because there's debris that's coming. So when a launch is being planned, they obviously have to work with those space monitoring people to understand what's in the area and what they know about. They can only plan for what they know about. And make sure that their trajectory will go past all of the debris and the space objects. But the problem is, the more things we put into space, the more things we have to track. It's getting harder and harder to track everything. There's a lot of group sort of deployment of CubeSats and things at the moment. You know, a spacecraft will go up and just shoot out a whole bunch of CubeSats. It takes quite a while to figure out which one is the one that was yours. Is it working? Is it going to communicate back? Is it not? Is it dead on arrival? Did it, you know, get bumped a bit and, you know, the antenna's fallen off? It's a lot. It takes a lot of effort and a lot of time and a lot of people, and it's a global problem. We need to work around the world to make sure everybody's working with it, to know where everything is. As Australia, we can see the southern hemisphere. Not many other countries can see the southern hemisphere, so that's a big part we have to play. So in short, yes, it is important to know where your space debris is, and as a space agency, we encourage the not creation of space debris. We're trying to make sure that our space industry is ready to go into space in a sustainable and safe way.
Fantastic. I think that answered that question very nicely. Now we are at 2:45, so unfortunately that is all the time that we have today. I'd just like to say that we've had some really great questions coming through, and I apologise that we haven't had a chance to answer all of those. So I'd once again like to encourage any viewers with questions either that we didn't get to or that they didn't have a chance to ask to send us an email here, or otherwise to come into the centre. As I say, we are always more than happy to have a chat and answer any questions we can. So yeah, definitely recommend a visit into the Australian Space Discovery Centre. Now I'd like to thank you, Liz, for joining us today. It's been really interesting to hear all about your journey and your role and some of your many fantastic insights into the space industry and the space agency here in Australia. So thank you very much for joining us today.
Thank you.